You know, you're online right now. You've probably already clicked on a dozen links today without even thinking about it. But have you ever stopped to wonder about the invisible bodyguards that are protecting you with every single one of those clicks? Let's take a look at what's really going on behind the scenes.
So who is it? Who are these digital bodyguards? Is it some super complex antivirus software you installed? A whole team of cybersecurity experts watching your every move? Well, the answer is probably not what you're expecting. Believe it or not, some of the most powerful protection you have online comes from something you will never, ever see. It's just a single line of text, a simple instruction sent quietly from a website to your browser. That's it.
Now, to really get why these simple little instructions are so critical, we kind of have to face a hard truth. The web, by its very nature, has some serious dangers lurking just beneath the surface.
I'm talking about things like data sniffing, where attackers can literally eavesdrop on your connection to steal passwords. Or code injection, where malicious scripts get slipped into websites you actually trust, tricking you into giving up your personal info. And these aren't some rare theoretical attacks. This kind of stuff is happening behind the scenes all the time.
So, how in the world do we defend against all this? Well, it's not with more complexity. It's actually with a clear, simple security rulebook, a set of basic instructions that tells your browser exactly how to keep you safe.
And this rulebook is made up of something called HTTP security headers. Now, these aren't complicated programs or anything like that. They're just simple, direct instructions that a website server sends over to your web browser.
Honestly, the best way to think about them is like a team of security guards for every single website you visit. Each guard has one specific job, one specific rule to enforce, and they all share a single goal: protecting you and your data.
All right, let's meet the first guard on our team. This one's job is simple, but absolutely crucial. Make sure you never, ever take an unsecure path to the website.
This guard is called HTST, which stands for Strict Transport Security, and its rule is absolute. It tells your browser, you are only allowed to talk to this website over a secure, encrypted HTTPS connection, period, no exceptions.
And the process is just brilliantly simple. The very first time you securely visit a site, the server tells your browser, hey, from now on, only use HTTPS to talk to me. Your browser just remembers that rule. So in the future, even if you accidentally type in an insecure link, your browser fixes it for you, automatically upgrading the connection to be secure before any of your data gets sent. And this is what that instruction actually looks like. See? It's just one line of text. The most important part here is max age. And that big number? That's just the number of seconds in a year. It's telling the browser, hey, enforce this HTTPS-only rule for the next 365 days. Got it?
Okay, so that's our first guard, securing the path. Our next one is totally different. This one acts more like a bouncer at some exclusive club with a very, very strict guest list for any content trying to get onto the page. This is the Content Security Policy, or CSP for short. Its whole job is to stop those nasty code injection attacks we talked about. And it does that by giving the browser a guest list of approved places to get stuff like scripts and images. If a source isn't on the list, it doesn't get in. It's as simple as that.
So here's how it works. The server sends over the policy. That's the guest list. Then, for every single piece of content the page wants to load, your browser acts as the bouncer. It checks the source against the list. If there's a match, great, it's allowed in. If not, it's blocked on the spot. No questions asked.
And here's a quick example of the CSP rule. This first part, default source self, basically means, by default, only trust content from my own domain. But you can add exceptions, like we see here for script source, which also allows scripts to be loaded from a trusted partner, like a content delivery network. It's actually incredibly powerful and super flexible. All right, our final security guard today is a little different. It shifts its focus from protecting the website itself to protecting you, specifically protecting your privacy as you bounce around the web.
This one's called the referrer policy. Okay, so when you click a link, your browser usually tells the new site where you just came from. This is called the referrer. But sometimes that information can include sensitive data right in the URL, like what you just searched for, or even a password reset link. This header lets a website control exactly how much of that private info gets shared.
So this policy gives a website a few different choices. If you want maximum privacy, you can choose no referrer, which sends nothing at all. But a really great balanced option is strict origin when cross-origin. This policy is smart. It shares the full address when you're clicking around on the same site, but when you go to a different site, it only shares the main domain name, hiding the specific page you came from. It's kind of the best of both worlds.
And yep, this is what that balanced choice looks like in the code. Just one simple line that tells your browser how to handle your privacy with a little extra care when you navigate away. So let's just step back and bring it all together. What we've seen here is that really powerful security doesn't always need some massive, complex system. Sometimes the strongest defense you can have comes from just a few simple, clearly stated rules.
This is your core security team, and they're working in the background every single time you browse. You've got HTSS, the guard making sure you always take the secure path. You've got CSP, the bouncer, checking the guest list for all the content. And you have Refer Policy, which is like your personal privacy advocate, protecting your digital footprint.
When it comes right down to it, these simple text-based rules are so much more than just technical details. They are a fundamental layer of security that helps build the trust we all need to feel safe online. They prevent data leaks, they stop attacks before they can even start, and they help create a safer internet for all of us.
Which of course leaves us with one last, kinda nagging thought. If this foundational layer of security can be this simple to put in place, why isn't every single website on the internet already using it?